Okay, this video is about measures of central tendency, which is trying to come up with a typical value that represents the data or a central value that represents the data. And we're talking about mean, mode and median. So when it comes to mean, we need to, now we're talking about, let's say this is a sample, so we'll use x bar, is the sum of all those values divided by the number of values. So we need to add these up, and that comes to 451,950, and divide by the number of employees, which is 9. So that gets us 50,217. Mode. Now the mode here is equal to 44,500, and you can imagine that happening because there's probably a number of people doing pretty much the same role receiving the same amount of money. So that's the mode. And the median is the middle score, and if we're struggling to find the middle, there's a little rule that helps us. It's the nth plus 1 over 2 value. So there's 9 values plus 1 on 2, and that's 9 plus 1 is 10 divided by 2 is 5. So the median is the 5th value. Now let's not get it wrong, the median is not 5, the median is the 5th value. So if the numbers are in order, you need to count 1, 2, 3, 4. So this one's the median. So the median is the 5th value, and the 5th value is $48,100. Okay, just a little bit of discussion. Notice that the mean is higher than the median. The median is influenced by this high wage here, and that wage is probably the person, the manager, the boss, the CEO, whoever. But because it's significantly higher than the wage before, and every value contributes to the mean is dragged up higher, where the median is a positional thing. So you can have the general manager, if that's the general manager, can earn whatever he likes, and it will not affect the median, because the median is not based on individual values, it is based on position. So sometimes where you've got a collection of data where there's lots of values kind of the same, and then it tails out to significantly high values, sometimes the median is a better measure. Now this time we've got a table, and we need to achieve much the same thing. We need to find the mean, mode and median, and to find the mean we need to add up all the values. But because it's in a table, we just can't add them up in a line. But what we're doing is we're saying the table here is telling us that we have 9 families with 1 person per family, and 11 families with 2 people, 6 with 3, etc. So to find the mean, we need to find the subtotals of each of these. So if we had 9 ones, well, 9 times 1 is equal to 9. So in other words, all the 1 scores will add up to 9. All the 2 scores will, and there's 11 of them, will give you 2 times 11, which is 22. And then 3 6s are 18, 4 6s are 24, 4 5s are 20, 12 and 14. So in other words, there are only two families that had 7 in them, so the subtotal of the 7s is 14. And all of that adds up to 119. So that means that the mean, now because this is the total of the f times x column, we can think of this as being the sum of fx is equal to 119. But basically the sum of the values is 119. And because it's in a table and we've added up a column, we write the mean, and once again I'll assume this is a sample, as the sum of fx over the sum of f, because basically the sum of the frequencies is 40. There were 40 numbers in the original data. So the mean is equal to 119 divided by 40, which is about 2.975, which could be argued is about 3. The mode in this case, really easy. Have a look through your frequency column. 11's the highest, so the mode is 2. All right. We're not after the highest frequency, we're after the score with the highest frequency, so we're after 2. And the median is the middle one. So if we think about our little n plus 1 rule, n plus 1 on 2, I'll put that over here, is 40 plus 1 on 2, which is 41 on 2, which is 20.5. So really we need to know about the 20th score and the 21st score. We need a cumulative frequency column to help do this. So let's add this in. So that's 9 and 11 gives 20. 20 plus 6 gives 26. 26 plus 6 is 32. 32 plus 4 is 36. 36 plus 2 is 38. 38 plus 2 is 40. And if those two numbers are the same, the total and the last cumulative frequency are the same, that's good. That's reassuring. So what this 20 and 21st score. So here, this 20 tells us that the 20th score was a 2. So the 20th score was a 2. And then the 21st through to the 26th scores were all 3. So the 21st score is equal to a 3. So that means that the median, which is the average of those two, is the average of 2 and 3 is 2.5. All right, so that's what happens if you've got a table, but it doesn't contain groups. Now on to the next one. A group table is a fair bit more difficult. Although not really. Let's do the cumulative frequency. So 4 and 1's 5, 5 and 2 is 7, 7 and 5 is 12, 12 and 4 is 16, 16 and 6 is 22, 22 and 2 is 24, 20, 27, 28, and 2's 30 and 2's 32, which is that, so that's good. Now, to speed things up, we need to do f times x. We don't have a set score here for x. So we have to use the middle. So this would be 7.25, and the next one would be 7.75, etc. So that gives numbers here. So this would be 7.25 times by 4, which is 29. And the next one would be 1 times 7.75, which is 7.75. And if we add up that column, so the sum of the fx column, that comes out to 304.5. Okay, so the mean in this case, and I'll once again assume that it's a sample, is sigma. Sigma meaning the sum of the fx column over the sum of the frequencies, which is also n. So this is 304.5 over 32, which is 9.52 to 2 decimal places. Now this time the mode, let's go back. An individual mode's, we don't know. We've lost our original values. We've just been given this table. So we don't know. So the best we can do is talk about a modal group. And the modal group was the group that was 9.5 up to but less than 10. Okay, so that's got similarities with the mean. But this is, I shouldn't call it the mode, I should call it the modal group. because it's group data. Okay, now the median can be a bit tricky this time. So the median here, if we use our little n plus 1 on 2 rule, so there were 32 numbers plus 1 makes 33 over 2. So that's 33 over 2, which is 16.5, or the 16th and a half score. So if we go back to our table, we know that, okay, we know that the 16th and a half score must be in this group here. All right, because the 16th score was in this group, so the 16th and a half score must just be in the bottom. So it's going to be really close to 9.5. So if we use the interpolation method, okay, so we know that it's in the group of 9.5 up to and less than 10. So that's the group that the median's in. And in that group, there is 6. The frequency is equal to 6. Okay. Now, so with the interpolation method, to come up with the median, so the median is equal to the lowest number in the group, which is 9.5, right? Because it's part of the way through this group. And to get the part of the way that it is, we take our 16.5 and we subtract the previous cumulative frequency. All right, because we're half of the way into this group. So it's going to be subtract 16 over, now there's 6 numbers in this group, so it's half the way through the 6 numbers, and we need to times that by, and I might just rearrange this to 16.5, and that's times by the class width, so it basically goes from 9.5 up to 10, so that's a gap of 5. So by the time we do this is 9.5 plus 0.5 on 6 times by 5, it comes out at 9.54. So that's just a little larger than the mean, and it's within that same modal group. Okay, now remember, if you don't like that interpolation method, and it is hard, you can use a histogram now. This histogram hasn't converted very well in. We've got lines missing from it, but I think we can survive. Now, you have to put an ogive on top of this. So the ogive will look like this. It goes from the previous cumulative frequency to the new cumulative frequency. All right, and that's that, and that. Then you come up halfway. It doesn't really matter if you come up half or you come up the 16.5, but there were 32 numbers, so we come up to either 16 or 16.5, it won't matter. And we come across until we hit the line, and then we come down. And that value there lines up with, I've lost the numbers, but that lines up with 9.5 if you had the original where you could see all of that. So the graph isn't quite as good as interpolation, but it's not far behind, so that's how you can do it by graph. Okay,